मैं स्टार्ट ही करना है.
Yes, ma'am.
Okay, so we can start off with the class, right? Everyone has joined. Hmm. So last class we discussed on image compression, right? So what is image compression? Do you remember what is image compression? We have a lot of terms to study in image compression, right? Image compression means what? You're compressing an image or data without losing the quality or data, that is without hampering the quality or without hampering the original data. So that is image compression, right? So then why do we use image compression? Why is it used for? The image compression, it is used, its main goal is to reduce the amount of data, and it is only represents those data or like it only represents those data which is necessary. Okay, the rest it hides or it just deletes it. Okay, so this is, remember, do you remember this? This is the storage data. This is a function, and what is it use? It uses a channel. It uses a channel from to compress, that is for compression and decompression. They are talking about decompression also. So main thing is the information which is stored in the device, that is, suppose this is a function f of xy. So this function, that is this data, is used to compress it, but that before it is stored in the device, which is the storage device, and then for decompression purpose it is retrieving that data from the storage device. And compression decompression, it takes place with the help of some transmission, or it is also known as a channel. We have different types of channel, we'll discuss. Okay, so main thing is compression to decompression, we need a channel, and the storage device helps in storing and retrieving of the information and data. Okay, then we spoke on data and information. What is data, what is information, do you remember? Yes, data means some facts and figures, right? Yes, and data, it is conveyed with the help of information. And then we talk about data compression, right? Why is data compression used? So data compression, it is again same thing, image compression or data compression. Image compression means you are using compression techniques for an image. Data compression means you are using compression techniques for data. So data compression, it aims to reduce amount of data which is required to represent a given quantity of information while preserving as much information as possible. Okay, so today I'm taking revision classes only, okay, because we have so many topics, like DIP, only 2 units are left. We'll start off with fourth unit tomorrow, but before that you have to remember the topics. Okay, so data compression, then image compression, then data information, these all terms you have to remember every time. Okay, so data compression is this. Then again, what it is saying, uh, data, that is information, it can be represented by various amounts of data. So data and information, they are uh, that is, they are relevant to each other. They are not synonymous in terms, but they are relevant to each other. Okay, then compression ratio, you remember? Yes, what is compression ratio? That is, you are given original data set, and this is the compressed data set, and compressed data set is achieved by performing compression on the original data set, right? So original data set is, suppose they are denoting it as n1, small n1, and compressed data set it is denoting it as small n2, right? So compression ratio is determined as original size by the compressed size, and this size of the image is termed, it is in terms of bits. Okay, so CR, that is compression ratio, is also denoted by CR, that is CR equals to n1 by n2. Then data redundancy. What is data redundancy? Do you remember these terms? Yes, do you remember these terms? Okay, so then I won't discuss again and again. Okay, then okay, then types of data redundancy we discussed. And that is what is the main aim is that we have irrelevant data in the image. Okay, suppose there are, in terms of image I'm telling, suppose there are irrelevant data in the image. So the main goal of data redundancy is to remove, that is main goal of compression. Actually the main goal of compression is to remove the data redundancy. And we have three types of data redundancy: coding, interpixel, and psychovisual. So compression, it attempts to reduce any one of these data redundancy types, then only compression is said to be successful. Okay, then coding, this is coding redundancy. Then uh, we have coding redundancy cases. We had two cases, that is redundancy of constant length and redundancy with variable length. Then interpixel redundancy, that is it is related with pixels. That is, if you if suppose you don't know a particular pixel value, but suppose the particular that is the neighboring pixels, that is interpixel redundancy, it implies on pixel values, and these pixel values are correlated. That is, a pixel value can be reasonably predicted by its neighbors as well. Okay, so this is the original image, and this is after performing interpixel redundancy, and this is the gray level histogram. Okay, then we had why how this interpixel redundancy is reduced. This is reduced by transforming data from one part to the other, that is one format to another format. And example, they use thresholding, DFT, DWT, these terms. Okay, then psychovisual redundancy, it is related with the human eye. Okay, that is you come across various types of objects in day-to-day life, right? So the human eye, it responds with different types of sensitivity, but it does not respond with equal sensitivity to all the information that is being seen by it, right? So it is saying that it is more sensitive to lower frequencies than to the higher frequencies. So whatever the idea of psychovisual redundancy is, that whatever data is not uh, relevant or significant to the human eye, you just discard that data. Yes, then this is psychovisual redundancy. This is talking about quantization. We already spoke previously. Yes, so sampling, quantization. So this is the quantization technique using different sorts of gray level, that is different bits of gray levels. Okay, then we spoke on fidelity criteria. That is two types of criteria we have in fidelity. One is subjective and one is objective. And subjective, it is based on human observers. It is whatever the human eye is able to perceive in front of it. And objective means some mathematical definition is being used to fulfill that criteria. This is subjective criteria, that is rating is given in terms of the value. Suppose 1 to 6 values are given, and rating is given from ascending to descending order. And then it is described how the, so here fidelity criteria, it is used to describe the image quality here. Okay, so here it is describing image quality. So this is value, this is rating, and this is the description. Yeah? Then objective fidelity criteria, this is determined by some mathematical equations, and here this is acha, last time I asked you to go through these two topics, that is root mean square error and mean square error, right? So did you do the homework? What is root mean square error? See, these terms are not much I mean to say, this are not much complicated. Okay, thing is that you already got these previously, but you have to brush up. Okay, you have to brush up. That's why I asked you to revise these topics. So what is root mean square error? Hmm? Okay, what is root mean square?
It's the square root of mean.
Hmm? Not audible. Hmm. Mean square. What is mean square? No one. No one has done homework. Hmm? Okay, square root of mean value. Yes. Then what is mean square signal to noise ratio? Did you go through this term? Hmm? Okay, you have to do revision again. Okay. Okay, signal and voice ka mean square. Okay, fine. Only Tafazul has done the homework. The rest, what about the rest? Hmm? You have to revise these terms. Okay, these are not complicated, but thing is that you tend to forget these terms. So you have to keep on brushing up these terms. Okay, and these terms you don't have to remember each and everything. You have to just remember the equations. Okay. Then this is root mean square error for different for the same image it is taking, and then it is calculating with different values. Okay, it is using different values, and accordingly you are getting the output of the original image here. Okay, then we spoke on image compression models. Remember, we spoke on compression, we spoke on encoder and decoder. That is, before talking about image compression models, we have to know that image compression system is comprised of two structural blocks. One is encoder and a decoder. And encoder it performs compression, decoder it performs decompression. Okay, I hope you remember the terms compression and decompression. So this is encoder and decoder. This is the image. Okay, then these are the Acha, did I share this PPT with you people? I think I haven't shared this PPT. Okay, I have to actually finish off with these, but the rest of the PPTs are very tough, so we won't go through it. Acha, let me tell you. Do you remember the second unit? That is, first unit we have already done revision. Actually, we have to do 2-3 revisions in a month. Okay. So first revision, one revision is done. So let's do the second revision today. Okay, let's do the second revision because DIP we are far ahead of it. So only 2 units are left. We have sums altogether. So not much of theory left. We have only sums. Then, do you remember color models? Hmm? Do you remember the color models? What is color? What is RGB? What is HSI model? Do you remember these terms? Can you do this revision today if I give you? Like whatever you remember. Okay, see, these may be used for internal marks purpose. Okay, because we won't have sessionals, right? Sessionals also we'll have online, off, on and off we'll have, but we need some session. We need some internal marks, right? So for that purpose, we are taking assignments. Previously, to we used Google Classroom directly, but this time we are using we are using the help of Cisco, that is video app. So we have to do revisions also. So this is second assignment. Okay, can you do this assignment today? Take 20 minutes. Can you complete in 20 minutes? Yes, ma'am. Okay. Okay, so just take this revision for today. Like last time you did, right? You wrote and you gave me screenshots. So similarly, you can do that. You note down the questions. You solve it now itself. However much you can write, I mean, and then Don't use Google language, okay? Whatever you understand, because these questions, these topics have already been discussed in the class, okay? So kindly don't use Google language. Whatever you know, okay? This is just revision. Whatever you know, I just want to check how much you remember, okay? So very easy questions. Just take this down, and like previous assignment, you just write it in a piece of paper or in notebook, click it, and then you can send me in the group, okay? Just take 20 minutes, okay? Okay, no need 20 minutes. Take 30, say take 10 minutes. And if you don't finish off in 10, then you can submit it within today, okay? Is it visible now, Aman? Have you completed, guys? Okay, continue. Okay, no problem. Continue. Okay, guys, you can continue with your questions. You can submit it within today. Okay. The meeting is about to end. So I hope everyone was present today.
Yes, ma'am.
Okay.